The F-16 Fighting Falcon, often known as the Viper by its pilots, remains one of the most versatile, reliable, and widely used fighter jets in the world. When we talk about its maintenance and takeoff process, we are not just discussing a simple routine, but a carefully choreographed sequence of engineering precision, pilot skill, and advanced technology. To truly understand what makes this aircraft such a legend, it is essential to break down what happens before it leaves the ground, how it is kept mission-ready, and why it continues to dominate the skies, even decades after its first flight. Every mission begins long before the engine ignites. Ground crews perform extensive pre-flight checks that are part of the standard maintenance cycle. These checks cover everything from the aircraft's avionics systems to its hydraulics and structural integrity. The F-16 is equipped with fly-by-wire technology, which means that its control surfaces respond electronically to the pilot's input rather than through direct mechanical linkages. Because of this, the electronics and sensors need to be in flawless condition, and maintenance teams meticulously run diagnostics to ensure no errors exist before flight. One of the key aspects of maintaining the F-16 is its modular design. Unlike older aircraft that required long and complex repairs, the F-16 was built with quick access panels and components that can be swapped out or serviced with relative ease. This reduces downtime and makes it possible to keep fleets combat ready, even under intense operational demands. Crews often check the Pratt & Whitney F-100 or General Electric F-110 engines, depending on the variant. These afterburning turbofan engines are the heart of the jet, producing thrust powerful enough to propel the aircraft past Mach 2 to ensure safety and performance. Mechanics inspect the compressor blades, fuel systems, and afterburner modules, confirming there are no irregularities or where that could compromise performance. Hydraulic systems are another critical area of attention. The F-16 relies on hydraulics to control its flaperons, rudder, and stabilators, which are essential for maneuverability. Even the smallest leak could lead to catastrophic issues during high-G maneuvers. This is why ground crews often spend hours running pressure checks and replacing seals or lines when necessary. Alongside hydraulics, the avionics bay is carefully examined. The F-16's advanced radar, navigation systems, and targeting pods depend on clean electrical connections and software updates. Modern versions of the jet use the APG-83 AESA radar, which gives pilots advanced situational awareness and targeting capabilities. Maintenance technicians ensure these systems communicate properly with onboard weapon systems and heads-up displays in the cockpit. Another major element of pre-flight preparation involves fueling. The F-16 can carry both internal fuel and external tanks, giving it extended operational range. Fueling crews not only load the aircraft with the appropriate type and quantity of jet fuel, but also run fuel contamination tests to ensure no water or debris has entered the system. This careful process prevents flameouts or malfunctions during flight. Once ground checks are completed, the pilot begins their walk-around inspection. This isn't just symbolic. It's a crucial, final layer of safety. Pilots look for anything unusual like loose panels, tire damage, or leaks. The canopy is inspected for visibility and integrity, as even small cracks could expand at high altitude. Once the pilot climbs into the cockpit, the startup sequence begins. The aircraft's systems come alive, with avionics powering up, displays lighting the cockpit, and diagnostic screens confirming system health. The sound of the engine starting up is iconic. The F-16's turbine spools up with a rising whine, followed by the deep rumble of combustion once the afterburner section ignites. As the jet idles, ground crews remain vigilant, monitoring for abnormal vibrations or smoke. Communication between the pilot and crew is constant, ensuring everything runs smoothly before taxi clearance. Taxiing the F-16 to the runway showcases its agility even on the ground. With a tricycle landing gear and responsive nose wheel steering, the jet maneuvers quickly across the tarmac. Pilots run through additional checklists while moving, testing flight controls, flaps, and brakes. At this stage, the jet is fully armed and ready, depending on mission requirements, whether carrying air-to-air missiles, precision-guided bombs, or external fuel tanks. The moment of takeoff is a blend of raw power and refined engineering. As the F-16 lines up on the runway, the pilot advances the throttle to full military power, then engages afterburner. The sudden surge of thrust is unmistakable, producing flames shooting out the exhaust and a deafening roar that shakes the ground. Within seconds, the aircraft accelerates rapidly down the runway, often reaching speeds of over 150 knots before lifting off. Its lightweight airframe combined with its powerful engine allows the F-16 to climb steeply, often demonstrating near vertical ascents at air shows to highlight its incredible thrust-to-weight ratio. During this initial climb, the fly-by-wire system ensures stability, even under extreme acceleration. The pilot's controls are interpreted by computers that make constant micro-adjustments, allowing the aircraft to respond smoothly and prevent stalls. The landing gear retracts, and the F-16 transitions seamlessly into level flight. From this point onward, the jet is fully mission-capable, ready to intercept enemy aircraft, deliver precision strikes, or conduct reconnaissance, depending on its configuration. What makes the F-16 unique in terms of maintenance and operation is how user-friendly it was designed to be for both pilots and ground crews. Unlike many fighter aircraft that require extensive downtime, the F-16 was built with cost-effectiveness and sustainability in mind. Many nations that operate the jet have praised its ability to remain combat-ready with relatively quick turnaround times between missions. Its single-engine design, while requiring meticulous inspection, reduces complexity compared to twin-engine fighters. Performance-wise, the F-16 remains one of the most maneuverable jets in existence. Its bubble canopy gives pilots unmatched visibility, crucial during dogfights and landings. The side-stick controller, unusual at the time of its introduction, allows for precise control during high-G maneuvers. These design elements have stood the test of time, keeping the F-16 competitive even as fifth-generation jets emerge. Another important aspect of its design is the ability to integrate modern upgrades. Many F-16s in service today are decades old but remain state-of-the-art because of continuous improvements in radar, targeting pods, and electronic warfare systems. This upgrade-friendly design reduces the need for entirely new aircraft while keeping the fleet mission-capable in modern combat environments. From a layman's perspective, the excitement lies in the sheer spectacle of watching an F-16 roar down a runway and leap into the sky with seemingly effortless power. But behind that spectacle are thousands of hours of engineering design and careful maintenance routines that make it possible. Every bolt, wire, and panel has been checked and ensuring that when the pilot pushes the throttle forward, the aircraft responds with absolute reliability. Even more impressive is how the F-16 serves in so many roles. It is not just a dogfighter, but also an attack aircraft capable of precision strikes, electronic warfare missions, and even reconnaissance. This versatility places additional demands on maintenance crews, who must be familiar with a wide variety of weapon systems and mission profiles. Whether loading AIM-120 MRAM missiles for air superiority or JDAM bombs for ground strikes, crews ensure the integration of these weapons with the jet systems is flawless. The takeoff process also highlights how well-balanced the aircraft is in terms of thrust and aerodynamics. Many jets require long runways or specialized assistance to get airborne, but the F-16 can take off quickly and adapt to different environments. Whether operating from large bases or makeshift runways in forward-deployed areas, this flexibility is another reason why over 25 nations continue to operate and upgrade their F-16 fleets. For aviation enthusiasts, what makes the F-16's takeoff sequence so thrilling is the combination of sound, speed, and climb rate. Few experiences compared to standing near a runway as an F-16 ignites its afterburner, producing a wall of sound that resonates through the chest. Watching it lift gracefully yet aggressively into the air demonstrates why it remains one of the most iconic jets in history. From a technical standpoint, maintaining such a high-performance machine requires constant attention to detail. Even after a successful takeoff, the jet's systems are monitored continuously. Post-flight, maintenance cycles repeat, with ground crews inspecting the aircraft immediately after landing to identify any stress, wear, or damage. This cycle ensures that every mission is supported by a robust foundation of engineering and human expertise. In summary, the maintenance and takeoff of the F-16 Fighting Falcon illustrate a perfect balance of engineering, technology, and human precision. Its design enables fast turnaround times. Its systems demand meticulous care. and its takeoff remains one of the most thrilling demonstrations of air power available to watch. The F-16 continues to be not just a fighter jet, but a symbol of adaptability and endurance in modern aviation history.